Welcome to the Future of Structures podcast, where we talk to the experts who are evolving our buildings for tomorrow. And here is your host, Adam Jones.
Today we are speaking with Jannie Van Deventer, who is the CEO of Zeobond. So they make Geopolymer Cement, which is quite different to Portland cement, which is you're about to hear all about. So essentially they don't have the same emissions as Portland cement because they don't go through the same reactions at such high temperatures. So this is a very relevant topic as cement is 8% of world emissions at the moment. And for a lot of people, it's one of those things that people do think is inevitable and then can't be avoided. But if you speak to Yanni, then he has potentially the solution to get cement and concrete down to zero emissions and having concrete strengths that can potentially exceed 100 MPa. I really enjoyed speaking to Yanni. He is a very smart man who is on a mission himself and has some very good opinions on the construction industry as a whole as well. So without any further ado, here is Jannie Van Deventer.
Hi. I was a chemical engineer who knew nothing about concrete and get involved in 92, 93. I spent some time in Europe and I got in contact with the early days of the development of geopolymers. So back in South Africa, I started doing research, and my main area of research was and continues to be of mineral processing. So I still have a heavy involvement in that field, and both have to do with particles, so they are relevant. But coming to Australia, I have since end of '95. I have done, I would say, less minerals research than I had before, and I've got stuck into this alternative type of cement. I was Dean of Engineering 2003 to 2007 at the University of Melbourne. I continued with the research both in minerals and also in cement. But since 2010, I have been really doing my own thing, and have been half-time involved with Zeobond and half with mineral processing projects. But I had to learn a lot about cement and also concrete, not being a civil engineer by background. But I had to really get stuck into it.
Yeah, cool. So in the early 90s, when you were looking at geopolymers back then, what was the driver then? Was it because it's obviously sustainability now, or was it different things pushing people toward geopolymers? And maybe what are geopolymers if we kind of break that down to a real basic level?
When I started, I'll cut a long story short, but when I started with this, it was as part of a waste processing project where we looked at both organic waste and inorganic waste. And in treating the inorganic part of the waste, we had this alkali activation technology, which when I started reading about it, discovered that it's called geopolymer, or was called geopolymers at the time. Now, what is a geopolymer? The name geopolymer and alkali activation are used interchangeably. And without making a long story about that, if you'd use normal cement, so we can just as well tackle the issue as to what is geopolymer cement, but we also need to then understand what is normal Portland cement. In Portland cement, you have calcium silica hydrate phases that form. Basically, you take limestone and you calcine it at over 1,450 degrees centigrade, which releases about a ton of carbon dioxide for a ton of cement as total emissions. So it's very high emissions. That is because the carbon dioxide is included within, is encapsulated within the limestone. That you also use a lot of energy to burn that. So basically, about 60% of the carbon dioxide emissions come from the decomposition of the limestone, 40% from the energy use. Instead of that chemistry, what you can do is you can use other calcium aluminosilicates, such as fly ash, slag, volcanic ash, also clays. You can, if you heat up a clay and get rid of the water, you can form a calcine clay and you can take that clay and also use that as a component of these type of alternative cements. So if you add an alkali to that, or you add some other chemicals which enhance the reaction of those ingredients that I've mentioned, then you form binding phases which are not exactly the same as Portland cement, but are related to when you take Portland cement and you mix it with fly ash or slag, as everybody uses these days with blended cement. So think of blended cement. Just think of a very high percentage of these supplementary cementitious materials, where their activity is usually low, and you use the alkalis to enhance their reactivity. That is just in a nutshell what the geopolymer is.
Yeah, nice. And you say adding an alkali. So what exactly is an alkali for everyone who's not aware of it, including myself?
There are various alkalis that you can use. Of course, the strongest alkali would be sodium hydroxide, which we do not want to use because it is not friendly on people to use it. But a strong alkali like that would really break down a refractory aluminosilicate network. As we do not want to use that, we use other materials such as sodium carbonate, which is a natural material available. It's being mined widely in the US, and there is abundant supply available. There are also other reactions, without going into the chemistry, that we can use, which are not totally alkaline activated, but are another form of activation where you enhance reactions, and where we come much closer to the supplementary cementitious material chemistry that is used currently in Portland cement. We just push the levels of supplementation of substitution much higher. So anything that you could use to enhance these reactions would be called an activation process. So personally, I prefer not to talk about alkali activation, but just activation or activated cements. And that means you use something else to activate, but Portland cement. Also, I have to add that you can actually use some Portland cement, or Portland cement is made of clinker plus gypsum. So if you do not like the gypsum as part of the chemistry, you could use just the clinker. Not so easy to get hold of, but fundamentally you could use that and actually activate that, which then means that you give a boost to the reactions on the fly ash and slag, for example, or clays.
So I guess the main reason people would go toward a geopolymer over Portland is it the sustainability reason, and you mentioned there was like 1450 degrees reactions for Portland cement, and can geopolymer cement be or concrete be formed at room temperature, or no high temperatures needed at all?
You have to apply these alternative cements, concretes, in the same way as normal Portland cement. Otherwise, they would just not be taken up in the market. So yes, you can apply them you have to apply them at ambient temperature. The whole range of so-called polymer cements is extremely wide in composition that you can use. So it's a question of tailoring composition to suit whatever source materials are available, and also what application you have in mind. So it's not one size fits all type of chemistry here, but you can apply this for just about any application that you can use in Portland cement.
I guess it's very exciting times for being in your industry, because cement emissions at the moment are 8% of global emissions, and it's something that's kind of underrated, I think. So who do you think has the responsibility for bringing this 8% down to zero? Because as a whole society, I guess it's, we got to target everything and bring it down to zero. So who's responsible for this, do you think?
That is a very difficult question because it links in with the question that I skipped in a way, and that is, what is the driver for this technology? Also, you asked me what was the driver when I got involved in this.
Yeah.
Although that was 92, 93, it was actually emissions and at the same time utilization of waste. So adding value to waste. Now, those drivers are still very much there today. I think, in theory, at least, carbon emissions should be a driver for this technology. My experience that it is not a strong driver. You mostly look at cost, and ultimately the structural engineer wants to make sure that you tick the boxes of compliance with standards. And only then, after those boxes have been ticked, you would look at, yes, we can cut down emissions. It is then a question of a look good exercise rather than that there's an obligation to cut down emissions. So who should be responsible? Well, we humanity, all of us should be responsible, but we want somebody else to do it, not ourselves. I would say, and this is maybe not a nice thing to say for a structural engineering community, but I would say structural engineers, because of the nature of their compliance and liability, are probably more conservative, and also structural engineers. There are exceptions, of course, but probably has less of an interest and knowledge about cement chemistry. So when you say something is not Portland, the structural engineer typically sees risk. The structure is going to fall down. Is the structure going to last? So durability comes into play, and you get into a very complex situation where if you use mixes of blends of Portland cement, which have been used for a long time, it's an easy tick-the-box exercise for the structural engineer. So I would say we can't put the focus all on the structural engineer. I think ultimately the asset owners need to take responsibility. I can't think that we can just put it all to government, but I think ultimately it is whoever would instruct that certain infrastructure, piece of infrastructure, whether it's a building or a bridge, whatever, has to be built, must take responsibility for the embedded emissions in that. And the moment that responsibility is accepted, it will come down the line to architects, engineers, everybody in the supply chain then has to take responsibility. But we have not seen that yet.
Mm-hmm. So you said that it's a way of adding value to waste. Do you think you see sometime in the future where the value of waste actually goes up so high that it actually might be a cheaper option than Portland cement at the moment?
There's a worldwide question about the existing source materials that are used for these alternative cements or for as supplementary cementitious materials, hence slag, usually blast furnace slag, granulated blast furnace slag, and also fly ash. In blast furnace slag is sort of in short supply. Fly ash is in short supply in some locations and in abundance in other locations, such as India. In Europe, for example, fly ash is in short supply and gets a very high price in the market. Even not for geopolymers, there's a technical reason why one would use a certain extent of fly ash in cement, and that material gets quite a premium. In fact, I know in Europe of fly ash being trucked from Poland through to the UK, which is a very long distance. It's not cheap getting there. That is such is the demand. We don't have that yet in Australia, but we do not have a suitable fly ash in the in the region of Melbourne, in Victoria. So we are trucking ash from the northern part of the country down, and that ash is not cheap by the time it gets to Victoria. So there is a shortage of these materials. Yes, in certain locations, but there's also a vast number of other possibilities, and I need to just spend a little bit of time on what they could be. Volcanic materials, volcanic ash and volcanic rock is available in many locations, including in Victoria. Also, clays, waste clays are available almost across the world. Whenever you have sandpits and the like, there's usually a lot of old clays available that are just lying there and not being utilized. It would not take that much to actually get that into the supply chain.
Yeah.
And it is possible. So there is no shortage of alternative materials to be used, but they are not part of the supply chain at the moment, and that gets us to one of the main challenges in applying these materials, which is an alternative supply chain. Now, this gets us to a chicken and egg situation. Investment in the supply chain takes substantial capital. Do you wait till that market develops, which is part of the existing cement companies that control the existing supply chain, in which case there's less of an incentive for them, despite claims to develop an alternative market for these materials, especially if it's going to cut into Portland, into the Portland market? Or do you set up an alternative new supply chain and then wait for the market to come, which is not what investors would like to do? I'm on record several times in saying this is the main hurdle in getting these materials into the market anywhere in the world.
Yeah. So it sounds like a bit of an economies of scale thing. So once you can ramp it up, there might be enough of a case for investors to set up these supply chains. Do you think? So do you think it's something that it's going to happen in the next few years? There's going to be a case for people to get on board with this?
Unfortunately, with cement, cement is a bulk materials handling business. That's to a large extent what it is. It also involves access to infrastructure such as port access. Shortly, we will not make any Portland cement in Australia. It will all be clinker imported and ground locally. That means you need port access to handle large shiploads of material and grind at the port. That type of real estate is under tight control, and it would be very hard for a newcomer to get involved into that supply chain. So I do not see that we're going to be able to set up a supply chain like that in the next 2-3 years in Australia, because you cannot linear market grows. You just extend the size of your shop, for example. You either do this at a large scale or you don't do it at all. There are many people who've looked at this, but nobody's actually had the guts to make this investment and then wait for the market to come. I am confident that from everything that I see in terms of awareness in the market, because of the number of emails that I get saying from all over the country, do you have this concrete available? We want to use this. And I have to say, sorry, we can't supply. There is a market out there, and once people see that it's available in a wider sense, the market will grow.
Yeah.
But I cannot see the investment right now.
Yeah. So I guess if there's any developers listening, and if they had a huge development or a huge area, will that be easier for you to set up some kind of supply chain for a big job like that?
Yes, it is. Adam, thank you for mentioning that possibility. I also want to raise an issue here of culture. In the construction industry, we seldom have total vertical integration. You have cement companies vertically integrated to owning their own quarries and also producing concrete, but that's where it stops. Somebody else buys the concrete and then transforms that into precast product or into cement in the ground in terms of in situ concrete. Usually, the companies that are involved in construction are either not interested in getting involved in the supply chain of cementitious materials, or fear getting involved for fear of upsetting their own suppliers if they're going to compete with what happens upstream. So it's a cultural issue. Some of the most successful applications that we had in the past in South Africa was indeed a case of vertical integration, where you had a construction company that could see that they could save money, which was the driver, and do it green, but mostly save money by getting involved in the supply chain of the cementitious materials, and that worked very well. We haven't seen that in Australia, but that is indeed where the opportunity lies for us to get involved in it has to be a very large construction project. There are several very large construction projects being planned in Australia right now. Any one of them would justify setting up a supply chain just for that, and doing all the processing of materials, and that will work. Yeah. So that's where the opportunity is, yes.
Yeah, fantastic. So what are some of the previous projects it has been used for, and some of the best uses for it that you've used in the past?
It has been in South Africa. It's been a range of projects, which includes also high-rise buildings and wind farms. In Australia, it's been smaller projects, but it's been, I would say, lower level projects. There have been some projects with structural concrete, and quite a few projects with panels, also precast, in situ precast structural concrete that's been used along freeways. A lot of footpaths, many kilometers of footpaths for house slabs, curb and channel, all those type of normal concrete applications have been tackled. So, because that's what you can do. What has been the case in the past is that we have been limited in terms of proximity of projects to producing the type of pre-mixed plant, because you do not want to transport any concrete too far, otherwise it's just too expensive and difficult. So we had a limited geographical range that we could do. With one of our licensees, we hope to be able to extend that reach across the Melbourne metropolitan area. But we get so many inquiries from all over Australia, New South Wales, South Australia, especially Queensland. So I think there is an opportunity for a much wider market out there. Yeah. But people do not want to deal with, in construction, they do not want to deal with a supply chain. They're so used to phoning up a supplier and whenever you want to, you get concrete delivered on site. That's what we need to put in place here too.
Yeah. And is it currently incentivised pretty well with the rating tools in Australia, say Green Star or the ISCA, Infrastructure Sustainability Council rating tools? Is there enough incentive to go with geopolymers at the moment?
I would say no. The parties that have been involved in drafting those guidelines have obviously had to make sure that the existing cement supply chain can supply something. There's no use for them setting goals that they cannot achieve with existing businesses. But that also means that the goalposts have not been they can move quite a lot. We can be substantially more ambitious in terms of what we ask can be done. But I think it will be difficult to move those goalposts it's again the chicken and egg situation without having the supply infrastructure in place.
Yeah, I think for me anyway, Yanni, I think in the long run, as buildings become more operationally efficient and buildings have to get to zero emissions and embodied energy has to go to zero, I don't know if do you think there's any other solutions other than, say, timber, but any other solutions where it can actually drive a building towards zero emissions, if that's one of the goals of the project?
If at some stage, well, let me give another angle. There is a trend towards, I would say, socially responsible investment at the moment. It is initially when this started, and it started with university investment funds in the US. People thought, well, this is just an academic idea. It's not really going to take up. Well, socially responsible investment is becoming really big. In addition to that, there is a substantial awareness of a growing awareness of the issue of embedded energy in construction materials. There's also, with the huge focus on infrastructure development internationally, there's an appetite for investors to look at investing into construction materials. So if you put all those elements together, it is probably the time that one would raise public capital to do exactly this. The issue with public capital has usually been that you need to show you've got a running business, which you won't be able to do unless you've got this in place. But I think we're getting to a stage where we may overcome that hurdle. So I'm not totally negative about this. I just don't see it happening immediately, but I do see it happening in the medium term.
Yeah, definitely. Yeah, I'd have to. I think it's a phenomenal investment for the medium to long term. And what about the standards? So the standards at the moment, so the AS 3600 for structural engineers, is there enough in there to be able to actually go with geopolymers? And is there anything on the horizon maybe to help that process?
Yes and no. Yes, we can at the moment. We can fit within AS 3600. Although I must say that, and we are often asked, do you comply with or don't you comply with AS 3600? And then I have to say yes, but on the other hand, yes, on the one hand, we do comply because AS 3600 is written in such a way that you have to have a minimum quantity of Portland cement in there. And if we therefore add enough Portland cement, we can actually massage a mix design so that we do comply. But the whole style of that standard has been based on Portland cement being the binder. So if you look at the implications of that, there are severe restrictions on what else you can use. For example, you are able to use only fly ash and slag, and you can use the high quantities, but you can't use anything else. It limits limestone because and it limits some other materials as well, or it excludes a lot of other materials that are possible candidates for use. Why does it do that? Because it had the best intent in making sure that you have stable phases that form when Portland cement is the main binder. That does not apply to these materials. Therefore, I would strongly. So yes, we can fit in. On the other hand, AS 3600 severely restricts us in terms of what we can do with this type of technology. It means we can't get into the supply chain of clay materials, of using more limestone. We can use limestone very successfully with the combination with clays and other materials. None of that can be done. And we don't have examples where we've built structures with that yet, because we have to always show we can fit into AS 3600. So any of these standards are severely limiting, even if the developers of them think that they have quite an open performance-based standard, but it's simply not the case.
Yeah.
So I'm a strong proponent of saying we need to move to performance-based standards instead of prescriptive standards. That means say don't care what's inside the concrete or how we get there. Say it needs to perform like this mechanically, chemically it needs to behave like that in terms of meeting durability criteria, but do not be prescriptive as to what's inside the concrete.
And I guess the other thing that might go with cement and concrete is steel reinforcement. So how does Geopolymers go with steel reinforcement? And when I went and saw you speaking last time when I heard you, you were talking about basalt reinforcement as well. Can you just tell us a little bit about that?
Yes. At the moment, so the short answer is yes. Geopolymer concrete is compatible with the normal steel reinforcement. There are some things that you need to do in the chemistry in these geopolymer type of mixers to make sure that you've got residual alkalinity to protect the steel. That's what we need to do. But it does limit you in terms of what you can do in terms of mix designs. So to me, being able to protect steel is severely compromising us in moving to an even higher level of concrete technology into the future. For example, we design concrete cover to have a certain thickness, not for mechanical strength, but because we calculate how long it will take for the concrete to basically carbonate up to the level of that steel, and that gives us the life span of the concrete. The moment we get rid of steel, we get rid of an enormous carbon emission issue, which has not been articulated because people assume, well, we have to use steel. Yes, we could look at an alternative concrete, geopolymers, but we really have to use steel. It's not correct. We can use basalt rebar. A lot of work has been done on basalt rebar, especially in the United States, where there's good technology available for producing basalt rebar on a cost competitive basis with steel. Now, this means that you take basalt, which is available just about everywhere, you melt the basalt, you put it into thin threads and you combine it again using a resin. Now, resin could be organic, but it could also be inorganic, where you combine these threads to make a rebar, and they are much lighter than steel, so you save on weight. They are as strong as normal steel, but they never rust. So you can literally make a concrete that will last forever.
Yeah.
I have to point out in this context that the Romans didn't have a problem with one reason why they didn't have a problem is that they did not have to think about protecting steel. Otherwise, the Roman structures would not have lasted this long. But we know many of them have lasted over 2,000 years. There's no reason why we can't make a concrete today in the same way. But it does mean that you need to use a certain type of chemistry to leave residual alkalinity. The Romans didn't have that problem. If we move more to a not exactly the same chemistry, but almost moving towards the more Roman type of mixed designs, then it really opens up much more what type of source materials we can use.
Yeah, incredible. If an engineer listening right now is really excited about what they're hearing and they want to learn more, so where do they go when it's for all this kind of innovative stuff that's happening? What's the best resources to learn more about it?
Adam, there's not one main textbook available. I shouldn't do self-promotion here, but we produced a very substantial report through Rylam with Professor John Provis at Sheffield University. So that gives you an overview of, that was published, I think, 2014, if I recall. That gives you an overview of the technology. But there are now several textbooks available. If you go on the internet, you'll find a huge amount of information, but you also find a few textbooks, more introductory textbooks on this type of of technology. I have to say that that's the technology often viewed from an academic perspective. There's been very little written on that technology from an application perspective, such as we have. And what none of these publications would do is to give you a view as to where this can go into the future. Like I've just mentioned, all these other raw materials that you could use, basalt rebar that you can use. I mean, I think the future for this is quite exciting. Yeah. But we need to get the investment to do that. And probably, if we look 10 years down the line, we look back, we will say, well, why was it so hard to get this off the ground?
Yeah, definitely agree. So, guess wrapping up now. So, what do you think will have the biggest impact on the buildings industry in the future?
There's three aspects. The one is shifting to a different concrete. That means using less cement, even more hybrid cements, but certainly moving away from Portland cement. We may not be able to move away totally from Portland cement, but I think we will use a very high level of substitution. That's number one. Number two, a huge impact will be moving away from steel. I do not see that happening at the moment. We are not pushing it hard because it's hard enough to push an alternative cement. So if people say, well, there's no steel in it, then the red flags go up. But that will have an enormous impact on the construction industry. It won't be good for Australia as a whole because we make money in this country from exporting iron ore. So you can imagine you are undermining a lot of mines in this country. That and there has to be a balance there. But if we look at construction, we can actually, as a country, be at the forefront of technology development and application internationally. The third aspect is that I think there are so many new possibilities of construction techniques that come in, where you've got more modularized construction, where it is possible to integrate these kind of novel construction technologies, material technologies, better into the construction project itself. And I think the next issue in terms of what will have the biggest impact is a general awareness when we have sea levels rising, and we can walk around the Australian coastline. You see how many places that get reinforced because of sea level rises. When it may not happen in my lifetime, but certainly after that, I think there's no doubt anybody still doubts climate change. It is real. It is happening, and I think that kind of awareness is really going to have an impact on how we do construction. But it's not there yet, and therefore, the type of I would say promotion and activity that organization like Beyond Zero Emissions is having in pushing this kind of awareness is extremely valuable. I think humanity will benefit from that, even though we are all just looking at our own little interests at the moment.
Hey guys, Adam here. Just before you go, just one quick request. If you're enjoying the show, please leave a review. It helps our rating and ranking on iTunes, so more people can hear from the people who are making our cities better places for our future.